All right. So tell me what you have. 2. Oh, wait. Yeah. Hold on a sec. So 2 square root of 5 over what? Over 3 root 3, you mean, right? Okay. So what? There's like one particular thing that's ugly about this problem. What's the ugly? Yeah, is it that there's square roots in the bottom? You're not allowed to do this. Like, leave it like that. Okay? All right. So, side note over here. What is, that's a thought bubble. What is 3 over 3? 1. What is 10 over 10? What is the square root of 3 over the square root of 3? But wait, 3 over 3 is 1, and 10 over 10 is 1, and heart over heart is 1. So what's the square root of 3 over the square root of 3? But wait, the snowman over snowman is 1. What? So what's the square root of 3 over the square root of 3? 1. No, anything, like if you have the same thing on top as the bottom, you're dividing it, the answer is always 1. You with me? All right. So I'm going to multiply, like, let's say I had this fraction. Here's another thought bubble, by the way. Let's say I had this fraction of 3 over 17. And I multiply it by 1. What do I get? 3 over 17. Well, let's say I have 3 over 17. I don't want to do 3 over 17. That's a terrible. I guess I'll keep it. 3 over 17. And I multiply it by 2 over 2, what do I get? 6 over 34. But then, do you know what 6 over 34 reduces down to? Oh, you should use it using your new technique on your calculator. So go get your calculator. Future Ashley, current Ashley said, ah. So, oh. Uh-huh. But you weren't watching my video. Yeah. Okay, so 6 over 34. What does that reduce down to? Yeah. By golly, look at that. That's the same thing we got before. I mean, look, 3 over 17, well, that's that. But wait, but we multiplied 3 over 17 by 2 over 2 and got this totally different number. Then how the heck did it give us this one, which is the same as that one? By golly, let me tell you. Let's say you have some pizza, right? And you go like this, or you bring some pizza, and then you go to the bathroom, and I'm looking at this pizza, and then I'm like, I'm going to just go ahead and eat this pizza. She'll never notice. So this is how much pizza I eat. What fraction of the pizza did I eat? Half. All right. You weren't too happy with me, but whatever. Next day, same situation. But this time, to throw you off, I went like this and cut that pizza like that and ate this much of the pizza. What fraction of the pizza did I eat? Well, actually, I ate 2 out of 4, which is half. See, so if you reduce it, it's the same thing, right? So 6/34 is the same exact thing as 3 over 17. And the reason why is because I multiplied 3 over 17 by 1. You see that? All right. So over here, wait, one more thought bubble, and then we're ready. So what do you think? Let's see, 2 over root 3. I have to multiply top and bottom by what? To get rid of that denominator, to rationalize the denominator. What do I have to do to rationalize the denominator here? Say it again. Just the number 3 itself? Like, here you go, number 3. Like that? Like that? There. Do I do that? What'd you say? What'd you say? Okay, well, if I multiply it by 3 over 3, you're wrong. But watch, you have to know why it's wrong. If I go across the top, I get what? If I go across the bottom, I get what? No? Because root 3 can't talk to 3. So there's an invisible 1 right here. So this invisible 1 talks to the 3, so you get a 3. But then the root 3 talks to nobody, so you end up with your root 3. So you still have a root in the bottom. Didn't fix the problem. So you got to multiply, rationalize the denominator. You got to multiply top and bottom by root 3. Okay? And what is root 3 over root 3? 1. So are you really changing the value of 2 over root 3? No. But you're just rearranging it so that you don't get arrested. So then on top, what do you get? Okay, so what's the number on top? The first one. Okay, so on top you have 2 root invisible 1 times invisible 1 root 3. Okay, so only out of jail can multiply with out of jail, and inside of jail can multiply with inside of jail. That right? So this 2 root 3 is what this is right here. I mean, when you multiply it together. You with me? All right. So this is just not working. All right, so 2 root 3. And then what do you get on the bottom? Wait. So far on the bottom, you're multiplying root 3 times root 3. All right. Wait, what's 3 times 3? Yes, because if you know the happy face rule, you don't have to do that. You can just say root 3 times root 3 is 3. Or you could say it's root 9, which reduces down to 3. Okay? So one more example. You ready? This one applies directly to your problem. You ready? All right. So if you have 2 root 7 over 5 root 11. Do I want that? Sure. 11. All right. So how do I rationalize the denominator? Just the number 11, like times 11? Yep. And how come I'm allowed to do that? How come it doesn't change the value of anything? Yeah, because this number here is really just what in disguise? 1. All right. So what do I get on the top? Perfect. And then on the bottom? 121, but if you know the happy face rule, you're faster. Just the number 11? So what's the answer on the bottom? Yeah, because these are 5 times. Because you would get, if you didn't know the happy face rule, you would get 5 times the square root of 121, and then you find that the square root of 121 is 11, so then you get 5 times 11. 55. This one right here is the one that directly applies to this problem. Got it?